Hello, today we are going to learn how to bake things like particles into textures. And this is an example of a particle system from Houdini that we are bringing into Nuke as a packed or a baked texture. And you can do this with any kind of data you have in Nuke, like deformations or animations and anything. So let's jump into Nuke and have a look. So this is the particle system we did in the DOP lesson. And now I'm going to show how you can bake this into a texture. So let's just pause this for a moment. So just to reiterate what we did in the DOP lessons. So we did a simple DOP network where we had our own custom particle system. And we need to bring these particles now, first of all, as a geometry. So let's press tab and type geo. And then let's call this my points. And let's go inside and press tab and type merge. Or rather, let's type DOP import. And then let's select our DOP network, so my DOP accept, and let's fetch geometry from DOP network. And let's see what we get. So let's uncheck all these first of all. And let's look at this result. So I will go up to the object level and disable the DOP network view flag and display only our my points and see that we have the data we need. Okay, so if you now look at the geometry spreadsheet, then you can see we have positions and velocities on the point level and no other data. So let's bake the positions and velocities into textures. And to create textures, the old-fashioned way to do this in Houdini is with a COP network. So let's press tab and type COP and select COP2 network. And let's call this my COP. And go inside. And here we will create a VOP. So press tab and type VOP and select VOP COP2 generator. And let's call this bake, for example. And press P for the parameters and go to image. And here we can set the size to 1024. So usually if you go lower than 1024, then sometimes Houdini crashes. So you have to be careful there. And I will set the height to 64. So that will create one slice, and you could stack these slices and create bigger textures for several frames, or you can bake out each frame as one texture. Okay, and next we have the image planes. So here I am going to select color RGB and then add some custom planes. So we want a position, so let's call this P, capital P, and then use curly braces and type x, y, z. And that will define a position with x, y, z components. And let's also create our velocity. I will call this maybe a big V and x, y, z. Okay, and the raster depths, let's use 16-bit floating point, or you can use 32-bit depending on what precision you require. So I will use 16-bit in this example. Okay, so next let's dive into this new bake node and delete the existing nodes as usual. And here we will first of all bring in the points from the SOP node we just created. So let's press tab and bind. and let's call this points. And then press P and change the name to $OS for operator string. And this will use the same name as the node name. And then for type, let's select geometry string. And here we can type OP for operator. And then the path, so /obj/my_points. And now we can process this in a snippet node. So press tab and type snippet. And then let's connect the point from the bind node to the input of the snippet. And let's call the snippet bake instead. And press P on the snippet. And here we can edit our vex code as we saw in the COP lesson. So first of all, we need to see how many points we have in total so we don't overflow the texture we made. So I'm going to create an integer, so int, and I will call this numpt, and this equals n points, and with the parameter points. And points is the binding that we just created and added as an input. And we will also want to see how many points could fit at the maximum on this texture. So in the same way, I will type int for integer, and then I will call this max pt equals, that would be xres times yres. And this is the resolution of the texture. And next we want to see what is the current point we want to bring in. So for this I will type int ptnum, and that equals, so we have the coordinates as ix and iy for the current pixel that we are rendering into this texture. And we want to now calculate what pixel correspond to what point. So for this we are first of all going to take the y position and multiply by the x resolution. And then we will add the x coordinate. And I think this would be easy enough to understand why we do this, because each line has XRS number of points. So if you are at point number 2, for example, then we would go XRS times 2 points plus the X position. Okay. Anyway, so let's continue here. So now we want to determine, to grab the information from the point. So let's first of all check if this is a valid point, so we don't try to grab a point that doesn't exist. So I'm going to first make an if statement. So if, and I will say ptnum is less than max pt, and that will check that we are not outside the texture itself. And then and to end characters, and that would be num pt, or ptnum is less than num pt, and that will check that there exists geometry for this point number. And then we can do what we need with this point. And what we need is the color and the position and the velocity. So for the color, I will say vector c equal, or I will call this color equal, and then I will just set this to 1 1 1, because we don't have any colors on the point, so there is nothing to bring in. So this is just a constant color. And we also want a vector P for position. Let me just call the color C just to keep it consistent. And this I will initialize to 0, 0.0, 0.0, 0.0. And the same with the velocity that I will call a small v. And don't forget to end the lines with a semicolon. Okay, so when we have the color, position and velocity, we want to output these. So for this I will check what is the current plane that we are rendering into this texture. And the planes are the color, position and velocity that we defined before. So I will do an if statement, and I will say if pi or pl for the plane is 0, and that is the first plane, then I will define cd color red equals cx, and for the other two components, color green and color blue, is cy and cz. And for the other, if the plane is 1, then we will use the position, because that means we are currently rendering the position. And if the plane is 2, then we want the velocity. So we will set the output to be the velocity, Vx, Vy and Vz. Okay, and let's now also grab the velocity here. So I will say P equals point, and then we have the points parameter, points, and then quotation mark P quotation. That means we want to grab the position attribute, and we should grab the attribute for point number ptnum. So type ptnum and end with semicolon, and do the same for the velocity, and change the attribute name to a small v. And don't forget to save, because when you do COP stuff, Houdini often crashes. So this should be enough. So let's look at the result. So let's add, if you go to new pane type, new pane tab type and composite view, then it actually created a node for you if you didn't have one. So let's go back to the OBJ and to my cop and look at our bake node. And now we can see we have a color that is white, and we set this to be white. If you look at the code here, so the color is 111, so that is correct. And you can also press I to look at the actual values here. And you can look at the other planes if you go up here and select P for the positions. And here you can see the position values. And you can go to V for the velocities, and you can check your velocity values. So let's, for example, go to P and press play. Then you can see that these values are changing for each frame. And now if we add a save, so press tab and ROP file output, then we can save these to disk. And let's press P to edit the parameters and set your frame range. So in this case, 48 frames. And for the output, I have defined a data variable. So data/EXR instead of render, and slash hip name slash OS, and let's leave this. And if you middle click, you can see this expands in my case to volumes data, EXR, etc. And you want to create the directory if it doesn't exist, and for the planes you want to save all planes, so let's use an asterisk here. And don't convert any color space because this is raw data. And the gamma should be 1, no lat. And next go to, let's see here. You have to be careful that the EXR compression is lossless. So I will use, for example, zip single scanline. So don't use DreamWorks animation for baked textures. And this is now good. So if you press render, then you will get all these textures saved. So in this case, one file for each set of color, position, and velocity. And then you can, for example, bring this into Nuke, as in this example, or you can bring it into your game engine or any software and use this to render in real time any data. So I hope this was helpful, and see you next time. Over and out.